Alright, in this video we're going to just quickly go over adding and subtracting surds. So the best way to remember what you can add and what you can subtract is to think about algebra. So in algebra, you know that we can only add and subtract like terms. So what I mean by that is if we had, say, 2a plus 3a, we add how many a's we have. So we have 5. So basically, this is kind of like an object. So let's say if we had apples, plus 3 apples, how many apples do we have altogether? We have 5 apples. But we can only add like terms. So we can add 2 apples plus 3 apples, but our bananas must stay separate. So we've got 5 apples, or 5a, and then we've got 5 bananas, take away 2 bananas, we have 3 bananas. And the same thing applies to surds. So a like surd is, let's say, the square root of 2 and square root of 2. They're like surds. So you could have any number out the front. As long as the surd part of it is the same, then they're like surds. Now with surds, you need to simplify them sometimes before you can actually add or subtract them. So the first one we have here is the square root of 8 minus the square root of 2. Now at the moment you're probably thinking, well, they're not like surds, but the problem is we can't tell until we've simplified the square root of 8. Square root of 2 can't be simplified any further, but the square root of 8 can. Now, if you need to, you can write all your perfect, missed 9, sorry, just get rid of that. Write all your perfect squares up the top of your page, just as like a quick reference. Okay, and you can keep going. So when you're simplifying, and hopefully by now you can simplify, you say, which of these numbers goes into 8? And which one is the highest? So sometimes you can have more than one perfect square going in, but for 8, we only have the number 4. So we rewrite the number 8 with 4 as a factor, so 4 times 2. Now, some of you will be able to skip this step, but if you're still a little bit unsure of how to simplify surds, then you can break this 4 and 2 into 2 separate ones. So now the reason we did a perfect square is because now the square root of 4 becomes a whole number, which is 2. And then we're left with just root 2 minus root 2. So basically, how many root 2's do we have? We got 2 here, and then we're taking away 1, so we're left with 1, root 2. All right, let's skip a few and do another one. So let's do E. Okay, so we're going to do this one here. So E is 4 root 18 minus 5 root 2. Now you've got to simplify this square root of 18 first. So the highest square, the 4 just stays there. So let's deal with the square root first. So the highest square number that goes into that is 9. So it's 9 times 2. And then we've got minus 5 root 2 here. So we're kind of just simplifying the root 18 first of all. You can separate the 9 and the 2. So the square root of 9 is 3. And for some of you, you'd be able to skip these 2 steps I've just done. So 4 times 3 is 12, root 2, minus 5 root 2. So just like we do in algebra, so if we had 12x minus 5x, now we've got 12 root 2 minus 5 root 2. So how many root 2's do we have altogether? We have 7 root 2. And as long as you can simplify, you'll be able to add and subtract. So I'm going to, I think I got another, oh no, just the one question. So to help you, if you need it, there are the solutions here. Okay, but the biggest thing you need to be able to do is to simplify surds. So if you're still having trouble simplifying surds, this is a good practice. But make sure you do understand how to do that, because if you can't simplify surds, then you can't add or subtract surds.